Hello everyone. So if you're new to the channel, please hit the subscribe button and like the video because we make videos around tech, DSA, placement preparation, resume, LinkedIn, and all of you need it for your placement journey, your college life, and after college as well, system design and all. So yeah, and if you like the content, to share with your friends as well. Also, we have recently started the OA series for you guys to prepare for your placement. That I prepare good question for you guys, how to approach a particular problem, and yeah, that's all for today. Let's try to get into this problem. Post-fix evaluation. This is an interesting problem. This is a come as a GFG problem of the day today. So let's try to see. Let's try to see. And also, I just want to share that okay, I have read your comments and you are supporting me a lot. I loving your comments. Keep posting, keep commenting. It's motivate me to make more such content, right? Okay. So post-fix evaluation, it is a known problem. Like it has always a problem of day many times before as well. Difficulty medium, accuracy 63%, submission too much points. Okay, fine. You're given a string array that represent a valid arithmetic expression. Okay, written in reverse Polish notation. Okay, postfix notation. Your task is to evaluate the expression and return an integer from its value. Fine. So it's like postfix, evaluate postfix. That's your eventual question. Postfix. What is postfix? Don't worry, we'll tell you in the video. Okay, let's try to read the question completely. The postfix expression they only explain is a form of operand operator. What happens is like what we do. Hmm, what we do generally, we write like this: one plus two is equals to three, right? Two into three is equals to six. We know this. This is infix notation that we as a human use, but does computer use the same thing? No, it's not like that. Sometimes other notations are required, not for us, but for computer to understand very well. Okay. So what a postfix does is it applies operand first, then operator. So it's like two, three, and plus, which is equivalent to two plus three. Means what it will do, it will put the plus sign between the two operands. So these are known as operands, operands, and this is known as operator. So operator means plus, minus, divide, multiply. Operand means on which the operation has been applied. Fine. But also one more thing, this you have to read this statement because I actually read okay, postfix expression. I know this. I can quickly code this. But sometimes it happens. The problem slightly changes. You should be very careful about that. The division operation between two integers always compute the floor value. It is guaranteed the result of the expression and all intermediate calculation will fit into a 32-bit signed integer. So that's a very good thing they told that you don't need to worry about. Oh, if you multiply two elements, like let's say you multiply 10 power 8 into 10 power 8, right? They can go out of bound, right? But they already specified there will be in range of integers, so no need to worry about that. That's a good thing. This you should know that you know a floor value, right? The greatest integer function. So if you do a 3 by 1, 3 by 2, sorry, it will be 1. It's not 1.5 and all. And also, you should see the constraint. It has negative elements as well. So if you carefully see it, minus 3 by 2, it will give you minus 1. That is wrong. You want a minus 2. So you have to handle this. This is the one of the edge case I forgot. So you should also understand. So I will always tell that what mistake I commit, you might also commit. So do let me know. I have list of mistakes that I've committed. Maybe you have also committed some of them, subset of them. Right? Always talk about subset. So this you have to handle that you have to make it minus two, not minus. By default, it will be minus one. Okay. For positive, no worries. This will be one only. So this is fine. So we have to worry about that. Okay. One more thing that I missed is basically they mentioned this operator. I thought this operator is XOR operator, but it's eventually turns out not. It's not a XOR operator. It's an exponent operator. Lol. Right. So you have to read the question properly as well. Sometimes examples also help from that. They gave the example, but I didn't read it. I assume this operator to be a XOR operator. That's one more thing you should be very careful about. And in the way we will see that what other things you should be careful about. Okay. Now, other than that, okay, how to solve this question? Like, what intuition comes to your mind? Like, there are two kind of scenarios. Either you have solved this kind of particular problem while you are preparing for DSA and all, and you are again back to here. Now you are recalling that, okay, how I solved this. This will also happens, right? How I solved this. I didn't remember that how I solved it, or either it's a new problem for you. We'll consider both the scenarios, and I will give you an intuitive way that how to think about that. Let's try to observe first thing. Always observation is the key. You try to write the example, you write derive some properties from here, and then you try to solve the problem. Okay. It's like this plus 9 and minus 9 and minus. This is the expressions they're given. Also, one more thing. They make the problem more simpler by not giving a complete string. Uh, that they can do that as well, that they can give you an entire string. You have to split into an operators and numbers. That would be more difficult and challenging problem because they have to handle more cases there, but they made the problem simpler by giving you an array of strings. So yeah, that's also interesting thing. So yeah, now let's try to do what is going to happen. It's going like this: 2 plus 3 into 1 plus and whole with minus 9. I hope this is the expression. Yeah, this they are trying to say, and this evaluate to what 5 minus 4, right? I hope this is minus 4. That my math is not wrong. Yes. How they did it solve it? Let's try to see it. How it could happen. Okay, I told you that. Okay, you know how to solve this. This is like 1 into 3, right? Now let's try to see what is going to happen. See, you go forward, you go forward. You don't do anything. Fine. But when you reach a particular operator, right, now you have to do something. Something you have to do. What they did, they eventually took the last two elements. Why only last two? Why not anything else? But if you try to see, okay, they did something on these two and they did not move forward. They do something more. Now this two is also remaining. This two also will be involved. This one more operator. Oh, that gives you a feeling. Okay, there's something like a stack thing. Why stack should come to your mind? Obviously, that's not very intuitive. I understand that point because you have some basic idea of stack as well. But yeah, you try to see that 3, 1, and then is a multiply. They did something to the last two expression, last two operate. That remind you of a stack, right? So, okay, you did something on that. Then you somehow put this result back into the stack again. Fine. And then you again check if another operator comes. You will do a plus here. And then you put again this element into the stack again. And then it's like 5, 9, and minus. It would be like, oh, you just pick another 5 and you put 9 and it becomes a minus 4. So what we are essentially doing, right? We observe something, okay, how this is happening. Try to read the example again. That, okay, this is how they did it. This is how they did it. Okay, they multiply 3 into 1, and I we know that what is postfix, and then we multiply these two elements 3 into 1. Fine, but what is the what about 2? Then the 2 is put it here. That somehow we computed this recent result, put back again. Then if we find again an operator, we just pick last two elements, something we are doing with that, putting the result back again, something like that. So, okay, by seeing this observation and getting the intuition, what we made an algorithm in our mind, we will use a stack. Definitely use a stack to track last two elements, track last two elements. Now it could be result computed as well. We'll see what I mean by that. results or direct element? Direct element. Okay. Like we perform some operation and we put back into the stack as well, right? So what we are essentially doing is we are iterating in the string and string. Now there are two possible scenarios. Either you find an operator you know that, right? I already explained you plus minus, and you find an operand. There are two kind of scenarios. Fine. What do you do? If you find an operator, then what do? You eventually find the top two elements, two top elements from stack. Basically, these are the last two elements. Right? That's how stack works. Last two from stack, and you perform that operation. You perform the current operation on them. We'll see what are the other demographics as well. That what if the it comes minus, then order also matters. We'll see how to judge that as well. Current operation. Okay, fair enough. Operand comes nothing, just push into the stack. Keep pushing into the stack, right? Now you will think about something. Now, first thing, whenever your mind is critical, right? Oh, you are saying top two elements. What if they're not top two elements remaining? There's only one element, or there's no element in the stack because we have popped it out as well. You're right. But in that scenario, the expression won't be valid. There has to be two operands in the stack for applying an operation. Okay. You cannot do a one plus something. It does not make any sense. Fine. So there will be two elements. So don't worry about it. It's a valid expression. They already didn't specify it clearly, but it is. Fine. So you got the algorithm, you do something and push into the stack. Fine, fine. Let's try to see with the help of example of this only 232 and 232 and this, yeah. Let's try to do that. 231 star plus 9 minus. Okay, and we'll also see in the game and how, what we do when we have the similar like this minus and what we do the order of the order. So you found a 2, you put into the stack. Okay. You found a 3, you put into the stack. You found a 1, you put into the stack. Now, as soon as you found the multiply, okay, what do? You pop out this element, this is second last one, and you do the operation. You do the operation 3 into 1, and you push back this into the stack. Our new stack looks like 2 and 3. Fine, fair enough. Then you found a plus. Oh, you again found top two elements and do the operation, which is 2 plus 3. Now, see, this is the resultant thing what we have computed lastly also. So it could happen. So we just push 5 into the stack. Okay, because we'll pop out these two elements. Now these two elements are do not matter because you already performed the operation. Now 9 comes, you push 9, 5, 9. Now this minus comes. Now there is a dilemma that either do top two elements you figure out 5 and 9, but what to do? Either do 9 minus 5 or 5 minus 9. In what in operands operator this will create a problem. It will create a problem in exponent. It will create a problem in minus. It will create a problem in divide. Right? In these kind of scenario, it will create a problem. So see again the example how they are rooted. See, when 5 and 9 was there, 5 comes 9. That means which one comes before should be put before only. Put at 9. That's how you observe it. And then you put back again into the stack. And at the end, when you are returned at the last, you're definitely sure only one element will remain same. Only the result remain in the stack. Result remains in the stack. Then you return it. If it is not the case, that means somehow if either you did something wrong or the expression is not valid. Other than that, you will always find you always sure that only one element remain, which is the resultant thing. Remain in the stack. So I hope you understood the entire intuition. The that what is postfix. Also, I tried to explain you how to resolve and solve the postfix as well. And then we saw the example as well and I run as well. Now let's try to see the code. Now I'll also see. show you the implementation of that. So it's very simple. It's not very difficult. It's a straightforward problem. Okay. So what we started with? We started with a stack. I initialize the int stack, all our strings, because we are doing the operations, right? So why to do on strings? Directly convert into integer, right? So we'll put integers into it. Actually, we're getting string as an input. So we'll convert integer into that. There are certain things. So yeah. Now I did two segregation. Is it an operator or it's an operand? So I wrote all the possible operators like multiply, plus, minus, divide, and exponent. This is exponent, guys. Okay. So then I found out two top elements, right? There will be two top elements. Then I did on the basis of that again, that what is it star, is it that, right? And then when this kind of operation about exponent and minus, remember that second last should come first in the order, then last. This is also an important edge case. Now this edge case you should add that. This is very important. Okay, this is very, very important. Okay, so what do? You do the division. Now you will check. Now you will check what thing that if it's divides, let's say 3 modulo 1, like it's like minus 3 divided by 1. It will be minus 3, no problem. Then you will check and also put absolute. Very, very important. Whenever you are doing the division, try to put absolute. Then also that will create a problem. We don't put absolutes, right? Minus 3 divided by 1. You know it is minus 3, but it does not know by compiler. It might create a problem. So always do an absolute is a better way. Okay. Then we will check if the remainder is not 0. Okay. That means it does not perfectly divide it 8 by 3. And they have like different signs, right? Then only it's a create a problem. Like minus 8 by minus 3, this will eventually is 8 by 3 only. So no problem there. But the problem comes in minus 8 by 3 or 8 by minus 3, right? That would create a problem. So we'll check there should be at least the fraction should be negative and the remainder is not 0. Then only we'll do a minus minus. Why? Because I already explained you 8 by minus 8 by 3 will give you minus 2, but the desired result is minus 3. Right? Greatest integer division floor, and then you finally either it's not the case, then you push the integer value of the string, and then you just return the top, which is the resultant thing in the stack. So I hope you understood the entire intuition, the entire thought process, the code and implementation, the edge cases you can make. And yeah, this is it for today, guys. And stay tuned for the further videos. We're coming with very, very awesome content. And like I am telling you, do subscribe to the channel and like the video and share with your friends because we're coming with too much awesome content, DBMS, operating systems, a lot of things I have thought about that. And you're showing love to the channel. Make sure to do the same forever. Right? Bye bye, guys.